Why are you in Protect, bro? There's nothing wrong with you. Ooh, pretty Cerwin Vega LEDs on the front. This is a pretty cheap and nasty 2-channel Class A/B car amplifier. Single-sided PCB, not good for reliability in an automotive environment. We don't have any adjustable bias on the outputs, which means they'll be biased pretty low. Really average build quality, loads of board flex, basic SMP. Yeah, nothing special about this whatsoever. Really cheap and generic. But as you saw, it's in Protect mode. We have 12.6 volts going in and it's not coming to life. What's interesting though is that there's no dead output transistors at all. No reason for this amplifier to be in Protect. So we need to dive in to the protection circuit itself, starting at the TL494. So the TL494 is what's generating the pulses for the power supply section, but it also deals with protection. It shuts down the amplifier if there's a problem. And this is how it does that. On the TL494, we have 4 pins that act as inputs for 2 comparators. So basically, if the voltage on pin 1 or pin 16 is higher than the voltage on pin 2 or 15, then the output of either of these comparators will go high, which means that pin 3 is high. And when pin 3 is high, it shuts down the oscillator and therefore it won't power the amplifier anymore. All right, pin 3 we can see here is high, up at 4.3 volts. That must mean that pin 1 or 16 is also high. So let's check pin 1. Oh yes, we're up at 9.7 volts and pin 2 is currently at 0.2 volts, so that's our issue. I've traced back where that voltage comes on pin 1 and it goes through this diode here, through this jumper, and it goes into pin 1 of this chip U302 here, which is a 4558P. That's just a pretty standard op amp. You can see that pin 1 here is the output of the first amplifier, so we've got in A, minus and plus here. So let's see what's on these 2 inputs. So pin 2, which is the inverting input, we have nothing, basically 0.2 volts. On pin 3, which is the non-inverting input, we have 10.36 volts. That's not good. If we trace pin 3, we can see that we have connection to the middle leg of this little transistor right here, 10.37 volts on there as well. Checking the outer 2 legs, we have 11.26 on that side and also 11.26 on that side, so they're the same voltage. Now that makes me believe that this transistor shouldn't really be on. It is a PNP transistor, so because the voltage on pin 1 and 3 is the same, we shouldn't really have an output on pin 2. So I'm going to pull this transistor and drop it in the tester and see if it's faulty. No, this transistor actually checks out. I've gone ahead and removed the 4558 op amp just to see whether the voltages on them are due to that being bad and leaking perhaps, and I noticed something interesting. With the op amp removed, the amp does actually try to power up. Probe the power supply FET. You can see we've got high current draw and a dreadful looking wave there on the power supply FET. We're drawing over the 6.7 amp limit that I've set on the power supply. Don't worry, that's not 16 volts. That's just the overvoltage preset. So what's causing that overcurrent and terrible waveform? Let's probe the gate leg of one of these FETs. Huh. Oh wow, it's not supposed to look like that. What it looks like we've got here is over 50% duty cycle on the turn on pulse, which is very strange. Now the TL494 can be run in 2 modes. First mode is single-ended or parallel output. On the second mode is push-pull output. For this amplifier, we need push-pull output. And in that output mode, the maximum duty cycle is somewhere a little less than 50%. So the fact we're seeing over 50% leads me to believe this might actually be in the wrong operational mode. The operational mode is just logic level set on pin 13, output control. You can see when this pin is tied to ground, the 494 is operating in single-ended or parallel mode, but when it's tied to the ref, which is 5 volts, it's operating push-pull. So let's check pin 13 on our amplifier. We have like 0.2 volts, so nowhere near the 5 volts ref that it's supposed to be. The 5 volt reference voltage for this pin is actually created by the TL494 itself on pin 14, which is 5 volt ref. So I assume that we don't have 5 volts on there either. No, we don't. So the lack of 5 volt ref might actually have been causing some issues in the protection circuit over here, as it likely makes use of it. So I'm going to replace the 494 as it looks like the internal regulator has failed, which would actually be extremely rare. So out it comes. Let's drop this nice fresh new one in. So with that fitted, let's check our 5 volt ref. Ah yes, that's good. So if I probe the power supply MOSFET drain and this starts switching and it comes out of Protect, the issue was just a faulty 494, which is super, super rare. Let's have a look. Oh, yeah! Yeah!